This conference will now be recorded.
Okay, so before we close for the other day, we said what is a repository. We started with telling what is a repository. A repository is also known as a source control manager or version control. And we said inside a repository, we work with something known as branches. Right? We said we work with something known as branches. And we started off initially with something known as a main branch, or we also call it as a master branch. So main or a master branch. And we said how do you interact with the repository, and to interact with the repository we said okay fine, to download your repository from the cloud to your local machine is called what? Clone. To upload a file, let's say from your local to the, let's say, the GitHub repository, this is called what? Push. If I create one branch from the other, it is called what? Pull. So we said okay fine, we have a couple of commands called git clone, git push, git pull, and we said all these commands are in sync used with, I mean all these commands are internally used in order to upload the files, download the files, in order to do a lot of things out here. And very importantly, this is known as branches. And we said branches are like folders that you can go ahead and create, and then let's say you can work with them, right? This is what we said. But every project, right, will have something known as a branching strategy, that which branch is used by whom, how can you use which branch, and etc. And that is what we are going to talk about today, very importantly, and asked very frequently in interviews, known as branching and merging strategies. This is very frequently asked, guys, and this concept is known as branching and merging strategies. So what is this branching and merging strategies, and how do we use it? What is the use case scenario of it? Let's begin this with an example. So let's go to the dev.azure.com and let's open up our project, which is called ATM class. And in here we said okay fine, you had a main branch and we had a readme.file and we had uploaded something inside it. Let's open up another repository here, and let's say this repository name is called a branch strategy. I'm opening up a repository and I'm creating a branch inside this repository, and the branch that I'm creating right now is what? A main branch. So I'm going inside this and I have a main branch. Now there is a policy of the organization that these branches are used by whom? A lot used by the developers. They have the code, they're pushing their code and etc. But being a DevOps engineer, I'll need to provision all these branches for them. I'll need to provision all these branches for them. And the first rule my organization has is that, let's talk about this. The first rule my organization has is that no developer should be able to directly commit on the main branch. Meaning this branch will always contain the production ready code. This is what we say, meaning the code that is ready to go live. This branch should always contain the code that that is ready to go live. So I cannot let my developers do a commit onto this branch directly. For which I can say, okay, fine. I can send out an email to, let's say, my entire development team telling that this branch is sacred. You're not allowed to go ahead and do a direct commit on top of this particular branch. Commit is doing what? Saving your files and etc. This is called as a commit. So I can send out an email communication to my developers. I can tell that, I can give their lead and etc. telling that, what, please don't use this branch for your direct commits. This is something that I can tell. But let's say there are new developers. Should I again send out an email to them again? Do I need to do an email communication every day? Not really. As a DevOps engineer, my primary responsibility is to protect this branch from direct commits. I should tell the developers, somehow I should communicate to them telling that, okay, fine, please don't do a commit on top of this branch. And one way to tell that is by using something known as branch policies. How do I go to, or how do I set up a branch policy? Is that if I go to a branch, I have three dots at the end. Click on three dots, and you have something known as what? Branch policies. And inside this particular branch policy, you have multiple things. Require minimum number of reviewers, check for link work item, check for comment resolution, limit merge types, and etc. We will see the three things. We are not covering these three things right now. We will see them a bit later. Let's understand require minimum number of reviewers. And I'll say one reviewer. And for now, I am saying allow requester to approve their own change. Meaning what I'm telling is that before someone commits their code here, I need at least one person apart from the person who's like committing their code to review these changes. Meaning, let's say I am using a readme.md file, or I'm using a text file, and I'm making a change onto the text file. This change should be approved. This is what I'm telling right now. And I'm just setting up something known as a branch policy. And inside the policy, I'm giving a rule telling that I need at least one reviewer to review the change. And I will say, okay, fine. I'll just come back. So I just set the policy. And as and when I set the policy, right, you have a badge here, see, telling that the branch has policies. So let's do one thing. Now let's say the developer doesn't know that this is a protected branch and he tries to commit on top of it. So I am the developer, I'm coming here. I don't know whether this branch is protected or not. Going here, I'll say edit. And just like the other day, what we did, I'll just go ahead and let's say add a file here. I'll just add a line here telling that this is a new line. I'm just adding a line here. And I should do what? Commit. I'll hit on commit. And I'll say, okay, fine, I updated this particular file. And I'll hit a direct commit out here. And as and when I do it, now it's giving me an error here telling that pushes to this branch, meaning you cannot push your commits to this branch. It is not permitted. You must use something known as pull request in order to update this branch. What exactly then is a pull request? Then how does a developer then update this file or update this particular branch? How does he do it? Let's see that. So let's say I'll cancel this. No matter what you do, you won't be able to do a direct commit on top of this branch. You cannot use this particular branch to do your direct commits. You cannot do that. So since I'm not able to do that, let's do one thing. I'll create a new branch. I'll say go to branches and I'll say new branch. And I'll say something like, or I'll say new branch. I'll say something like test branch. So I'm using something known as a test branch out here. I'm saying create. I'll say leave. And test branch has all these contents. Whatever I have made changes, whatever let's say was there in the main branch, all these are here. And my commit at the line number 21, which I said this is a new line, did not get committed because that branch had a policy. So what I'll do right now is that I am now a developer. I want to make a change here and I'll say this is a new line. And can I now commit here, guys? Yes, no, maybe. Yes, because I am working on what? Test branch, which does not have what? Policies. I did not enable a policy upon the test branch. So I'm saying commit. I'll say commit. I was able to do a commit right now. Now, whatever changes that are there in this particular test branch, let's say git. So I have a main branch here and I have a test branch here. Whatever changes that I'm now doing on the test branch should be now taken into the main branch. Should be now taken into the main branch out here. This process of taking, let's say, the change from one branch to the other, it's called a process of merging. And in here, how do I do a merge here? Is that After I did a commit, right? It's telling this is a new line. This is the content that I just added. And here I have all this history telling that I just updated something known as a readme.md file. Here, do you see something known as a pull request, guys? It now says, okay, fine. You are good to go ahead and create something known as a pull request. What I'll do here is I'll say create a pull request, or we also call this as PR in short, pull request. And I will say add a description to the pull request. I'll say added a new line in the file as recommended. I am doing this as a developer right now, and I'm saying create. Now I have a PR that got created right now. This pull request should be approved by someone. Why should it be approved by someone? Anyone? Main branch has a policy. And where am I doing this pull request? How am I doing the merge? I'm doing the merge from the test branch into what? The main branch. Main branch doesn't allow commits. It needs someone to approve this out. This is where the technical leads come into picture. The technical leads will have to go through the entire file changes. For example, how do they go here? So as and when someone raises a pull request, an email will get triggered to the to the lead and etc. They can use this link, come to this particular page, and they can look into what is the change in the file. They can say, okay, fine, these are the changes in the file. This is the change, and this is what the person is particularly changing out. And if I'm good with this, I can go ahead and give what? Approval. As and when I give an approval, right? Let's say approve. Now, in my case, it is telling at least one reviewer besides the author must approve this out. So I cannot approve my own change because the branching policy is something like this. Let's come down to my branch. This particular option, right? Allow requesters to allow their own change. In my case, this should be enabled because I am the only user in the entire organization. I do not have anyone else in the organization. So I have to make sure to basically put this on. I'll go back into my pull requests. Now you see one reviewer has approved this out. I have a tick mark here telling that one reviewer has approved this out. The change is good to be merged. The change is not yet merged right now. The main branch still doesn't have that particular line. That line is not yet added. I just approved it. After the approval is done, the change has to be completed. I'll say complete, and I will say the test branch was a short-lived branch. This is only for one purpose so that I can make some change and make a pull request out of it. I don't want this branch unnecessarily on the cloud because I'll end up wasting up a lot of space basically. So I don't want this branch unnecessarily on the cloud. So I'll delete this branch after merging. I'll say complete merge. As and when I complete the merge, it will now say the merge is done. And now if I go into my branches, you won't have the test branch out here because I deleted it out. And now the main branch contains all these changes called new line and etc. Okay. This is the first branching policy that I'm talking about. Is that I need someone to approve it. At the same time, I also want to leave scope for corrections. Meaning, let's say the change that I've done is not right. Let's say, how do I do a change again? Let's say I'll pull a branch again called a new branch, basing it out of the main. I'll say test branch one. I'm creating a branch right now. And inside this, I am writing something again. I'm saying this is a second line. I intentionally made a couple of grammatical mistakes, like this is second line and everything. I made this grammatical mistake. Let's say the developer does the same mistake on the code. He writes a different logic which is not right, and he did not check it properly, and he's now committing this out, and he's now raising a pull request to merge it into, let's say, the main branch, and he's giving some description and creating the main branch out here. Now the lead comes into place. He now wants to check this out. He will check this, and he says, okay, fine, this line, right, contains a lot of issues. It has a lot of grammatical errors and etc. I want to tell to that particular guy that there is a lot of grammatical issue and etc. Now I can basically send out an email again, but again, emails are all human, basically intervention. They might be missed and everything and all that stuff. Or you see an option to comment here. I can click here to add a comment, and I can say this line contains issues. Please correct it. Comment. As and when I comment it, you will be able to see all the comments here, telling that okay, fine, this is the line basically what someone has commented. This is where I need to change my work, or this is when basically I need to basically change what is my, change my work and etc. This is how the developer will now get notified, telling that okay, fine, you have an issue here. You will have to resolve this particular comment. These are called comment resolutions. That if someone is putting a comment, you'll have to resolve that particular comment out here. And in order to make sure that this is also one of the most important check before someone merges, I'll now go into my branch, into the main branch, and I'll enable something known as what? Check for comment resolutions. This is now a required change, or this is now a required parameter. Meaning, if there are comments, pull request merges are not allowed until and unless those comments are resolved. When can those comments be resolved? If I correct my change, right? If I now go into something known as my pull request out here, it says 0 out of 1 comments must be resolved. Until you go ahead and not resolve it, this comment will be in the same way. You cannot go ahead and do a merge. This is what it is telling. So what will the developer do right now is that the developer will go into his particular file, and he says this is the file basically that I have an issue with. I'll say okay, fine, there are a couple of things that I need to change. Now do a commit. So I'm doing another commit here, and once I go into my PR and I go into the files, this is now changed, meaning the PR is now, let's say, corrected. Now what I can do as a developer, since I've corrected this out, I can say it is corrected. Okay, reply and resolve. These are known as comment resolutions, and as and when I do a reply and resolve, now I said required check is succeeded, comments must be resolved, comments are resolved. Until and unless you don't resolve all these comments, even though I given approval, your PR will not get merged. And if your PR will not get merged, your changes will not get reflected in what? The main branch. So now I'll say complete the PR. This is the second check for me, which is telling that the comments must be resolved. The first was what? Required minimum number of reviewers, which is the first check, and I need at least one reviewer out here. Second check is what? Comment resolution. Now I also want to introduce something known as a third check. Now, if a developer is working on this particular change, that developer should be assigned that work, right? You cannot just go ahead and change the code as you wish. You cannot do that. You need something known as a feature for you. Meaning we said features, user stories and etc. And we said for a user story, you'll go ahead and work on the code. This is what we said. Now then, how I as a scrum master, how will I assign the work to the developers that I have? Using what will I assign the work? Using how will I track the work? This is where you have something known as boards. You have something known as board, and if I go into something called as a board here, this will just give you a place where you can track the work to. Meaning here you can add something called as a new item, and in here I can say please update a third line on the readme file. I can now assign work items. These are called work items or user stories, features, whatever you can call them as. And I can now assign these work items to a specific developer or to a specific DevOps engineer. How do I do that? I created a work item. I can say, okay, fine. This is the person that I want to assign to. I'll say save. This work item is now assigned to me. As a developer, this work item is assigned to me. And I can now say there are three things out here that I can do. Initially, it will be in something known as a to do, that I need to do this. I can then move this work item to something called as doing when I am actually working on this particular item. After I'm done, I can drag and drop it into done. These three are called swim lanes: to do, doing, done. They are called swim lanes out here, because if you go to a swimming pool, right, you'll have lanes in the swimming pool, right? This is representing that particular swimming pool, and that's the reason these are called as swim lanes out here. So let's imagine that I have this work as doing. So I now want to say that the developers should only change the file if there is a work assigned to them. Because if there is no work assigned to them, then why should a developer go and change the file, right? He should not be allowed to go ahead and change the file. If there is no work, if there is no specific work assigned to him, he should not be able to, or he should not be able to go ahead and directly change that particular file. Getting my point, guys? Because only if you are assigned a work will you go ahead and change the file in the branch. If there is no work, you shouldn't be allowed to do that. So that's the reason I now get something called as a third concept inside my branch. Into the branching policy, I'm again going inside the branching policies right now. I have two policies right now with me. One is minimum number of reviewers. I'm saying one. Second is what? Checking for comment resolution. Third is I'm saying checked for linked work items. This is also required. Only if there is a work item should you allow a change and should you allow the PR to be merged. Until this point, you should not be allowed to go ahead and do a change. This is what I'm now telling. So what happens right now is that let's come into my branches again and let's create a third branch right now known as test branch 2 or test branch 3, whatever it is. And I'm saying create it out of the main. And now I will go here. I will say this is line 3. I'll say commit. And while committing my change, I'll say added a line 3. I will say this is the work item that is compelling me to add a change, or this is a work item that requires me to go ahead and change this particular file. And I can link my work item that I've earlier created on the Azure board to the change that I'm making right now. This is how you link your work item, and I'll say commit. After committing it, now I'll raise a PR, and here I'll say added something, added a line, and the work item is already getting reflected because earlier when I did this change, I use this particular work item, and I'll now say create. Now the PR is created, and there are two checks out here. Work items must be linked, comments must be resolved. There were no comments, so that's the reason both the checks are done. The third check is what? Requires at least one person to review this change. So one person should come here, review, and approve your change. After that, all are greens, then you can go ahead and complete your changes out here. Okay. Now what does this give me is that it now puts me into a better place, telling that whatever changes are coming into my branch are legitimate changes, are expected changes. This is what I am now telling that okay, fine, I have these three checkpoints that I put in place, and each and every checkpoint is adding some value to the change that I'm making. Meaning, now if I go to a board as a Scrum Master, if I go to a board and if I now look at this particular work item, this work item has a related development. You see, whatever changes that I have made to a file are also being tracked here, telling that okay, fine, I added a line, I did a PR, and that particular PR was got merged. So this is how, as a Scrum Master, or this is how my team managers will now be able to track my work. That okay, fine, what work is this particular guy doing? Like when was this particular work item assigned? What are we doing till now? What is the development so far on this particular work? This is the second advantage what this particular work item gives me out here. And all these can be achieved using something known as branch policies. And how do you set up a branch policy? You go to a branch and you say branch policy out here. Any questions till here, guys? Any questions that I can take till here? Anyone? Anything? We can set up that, but it is not advisable to set up a branch policy for a test branch, because all these branches are used by the developers in order to make changes. If you even go ahead and set a policy to the test branch, right, the developer won't be able to do a direct change on top of it. So it doesn't really add a lot of value if I set up branch policies on a test branch as well. Okay.
So test branch is only for developers who can make changes and deploy into or commit into main branches. That's the only purpose we'll create a test branch or sub
Correct. I
branch.
mean, that's correct. So right now I haven't gone into a concept known as feature branches and etc. Right now I'm just calling my feature branch as a test branch, but we'll go into the concept known as a feature branch. We'll see how exactly a developer does a commit and etc. That will come under something known as branching or merging strategy. But yes, test branch are only for that particular purpose, and these branches are called as short-lived branches because they only exist for one purpose. After that purpose is satisfied, you delete that branch. All these are called as short-lived. So it doesn't really make a lot of sense if I want to put a policy on a short-lived branch, because I'll any which ways go ahead and delete it after the commit is done.
Correct. But why don't we create maybe one or two users here or developers so that the flow should be
Mhm.
visible, right?
So if I do that, so what will happen is that
Mhm.
I can go ahead and add multiple users into my account. But every time, let's say I do a pull request, I'll have to ask someone else to share their screen and approve that out. And that particular
Maybe some
person
other
should
user
also
it
be.
will desktop only. Some other user here itself. No, not possible.
I'm sorry, I
No,
didn't get
some
you.
other user here only. Maybe with you, with other.
But I'll have to log out, right? I'll have to log out, and that user has to log in back again. So in order to explain that particular flow, I can do that. Okay, I can also do that. Not a problem. I can add another user and I can log in like another
Maybe
user
remote
also.
desktop you can use, right?
I'm sorry.
We can have a remote desktop some, right? As a remote desktop. So there you can.
Okay, you can have a remote desktop. Like I'll say I'll
Mm.
basically go ahead and do an incognito window.
Yeah,
Not a problem.
yeah, yeah, yeah.
I can do that. I can go ahead and do that as well. Yes, I'll definitely include that as well. That's a good idea. I can do that. Any more questions here, guys? Approval. Your branch will get merged and your code will get reflected in production, and that'll cause an issue. That'll cause definitely an issue. So you are telling that here it's a manual approval yet. So there can be human mistakes. Definitely there can be human mistakes. That is where we have something known as static code analysis coming into picture. Automated approvals. We'll see how you can do that, and etc. in the coming classes. Okay, so this is how you go ahead and let's say update the branches and etc. Let's understand this a bit further. Let's go ahead and understand this cycle a bit further to see what happens in the real-time environment. How do we go ahead and use these branches in a real-time environment and etc. So what happens in a real-time environment is this. You will have a branch, right? Initially you have a branch which is called a main branch or a master branch. Main or what? A master. You can call this as a main or a master. This branch is protected by using what? Branch policies. This branch is protected by a branch policy. So this is 100% protected and everything. It's like you cannot go ahead and let's say do a direct commit on top of this branch. So what I will do, I'm saying that okay, fine, this branch should always contain the code that is ready to go to production. Meaning always contain the code that is ready, that is production ready. So this is a backup branch for me. This is what? A backup branch for me. Secondly, what I'll do is that for my developers to start working on, I will create another branch from this particular branch known as a develop branch. I'll create another branch known as what? A develop branch. This is for developmental activities. Okay. And this branch also has policies. Also, the developers, since that they are using this branch for developmental activities, I cannot allow the developers to directly commit on this branch. I will use something known as branch policies to protect even this branch. Even to protect this branch, I'll use what? A branching policy. So no developer should be able to, or no developer should be allowed to go ahead and directly commit their code changes on top of this branch also. Then what will a developer do is that a developer or each and every developer in my team using his local laptop, because developers normally work from their machines and connect to the cloud, right? Developers will pull another branch. This branch is called as feature branch. This is now known as what? A feature branch. A developer should use what? A feature branch, like the test branch. Like I use a test branch, the developers will call this as what? A feature branch out here. The developers should use this particular branch known as feature branch, make their changes, and then use that particular change to merge into the develop branch. Okay. So I am coming from a test branch. The developer is coming from a feature branch. And these feature branches are short-lived in nature. Meaning after the branch is committed, after the change is merged, this feature branch will be what? Deleted. Just like I deleted my test branch, developers will have to delete this particular feature branch out here. So once these changes are in, right? Now all the code changes are there. I said all the raw code changes are there. Like whatever the raw code is taken, I'm taking that raw code and putting it inside this particular develop branch out here. Now this raw code has to be converted into what? Machine understandable language, DLLs, or also called what? Artifacts. So using this branch, this is the source code that I right now have. Whatever development activities that I will do, I will use this branch as my what? Source branch. And I will now do what? A continuous integration on top of this branch. Now I'm just giving a very overview of everything. Even if it doesn't, I mean, even if people are not following at this point, I'm okay with it, because we haven't covered what is continuous integration and etc. But I'm just explaining what is the cycle at this point, like what is the general cycle that we follow, so that the later classes that we do will make much more sense, that what is the cycle that we are following and etc. I will do something known as a continuous integration, and this is the branch that I'll be using as my source for the continuous integration pipelines. I will convert the code, whatever is there inside this branch, into something known as what? Artifact. Or also known as what? DLLs and everything. So I am using a continuous integration pipeline, and I'm telling my continuous integration pipeline that, you know what, the developers are committing to the develop branch. So use the code that is there in the develop branch and convert the code into something known as an artifact. Once the artifact is converted, let's say I want this particular artifact to go into an Azure web app that is sitting in the Azure platform. I'll connect this artifact to something known as a CD pipeline, continuous deployment pipeline. And I will use this pipeline to take this artifact. Instead of Visual Studio, I'm not doing a publish right now using a Visual Studio. I am doing something known as what? A CD pipeline out here. Using this CD pipeline, I am now taking all these changes into the Azure environments. And as I said, I have multiple environments out here. In my case, an environment consists of a resource group and an app service inside it. That's it. Let's do a very simple environment. So I have a resource group and an app service that is sitting inside that particular resource group. So let's take the RG out. And let's take an app service inside that particular RG. And this initially is called as a development resource group. Dev RG. For what? Developmental activities for the developers to test their changes on the cloud. Second, after I deploy or after I take the code into the dev RG and the developers test it out, what will they test? They'll test the app service. They'll test to see if the app service is working fine after the code was deployed on top of it, successfully deployed on top of it, and etc. After they do it, I have something known as an environment 2, which is what? QA. We'll say a QA RG. Inside this, I'll have same an Azure web app, which has almost a similar configuration like the dev has. And this is for the QAs to test it. Because DevOps now accommodates all the teams like development, QAs, operations, and everything. This is now for the QAs to test what are the changes like. After the QA is satisfied, I will now take the code to an environment known as production. This is where I get in another web app, same configuration, same code. This is known as code promotion from one environment to the other environment. First environment is what? Development. Second is QA. Third is production. I'll say prod. And this environment, right, is directly exposed to the client. This is where the client comes into picture, meaning this web app is directly utilized by the client. Each and every web app has its own link, right? The two web apps that I have, which is dev and QA web app, is for internal purpose, is for my testing to see what are the changes and etc. And this production web app is for the client. The code is promoted to the production web app at the end of each sprint cycle. This model of operation is called continuous delivery, meaning at the end of each and every 15-20 days, I'm releasing an update. And my updates are going through this particular cycle. From the development, it is going into, let's say, something like dev RG. From the dev RG, it is going into something called QA RG. And from the QA RG, it is going into something known as what? Prod RG. This is how I am promoting all my changes to. Okay. Now, this might not make a lot of sense at this point because we are understanding what a branching structure is, like what exactly will we do, let's say, once we start DevOps with. But when we do something known as a continuous integration and a continuous deployment pipeline, this will make much more sense. We are going to do each and everything practically. But I first want you all to just imagine what this is on a theoretical level. Because these are the questions that are most asked on an interview, guys. Is that what do you know about the branching and merging strategy that is utilized in your project? What kind of branches do you utilize in your project? How do you utilize in your project, and etc. Okay. And these environments, right? Now the dev and the QA environments are called pre-production, pre-prod. This is called production. You can have multiple environments like pre-prod, staging, production, and everything. Okay. Now, one thing out here you'll have to observe is that the branch that I'm using right now is what? Development branch. Now, let's imagine that today is the 1st of December. To make it easy, I'll say today is the 1st of December. My sprint cycle, meaning the sprint cycle is how many days, guys? It's either 2 to 3 weeks. So, somewhere around 14 to 21 days. Let's say, let's say somewhere around 25th of December is the end of my sprint cycle. Meaning, at the end of my sprint cycle, what should I do? I should take the code to what? Production. So that the client gets a new update, because that's what I promised to the client. Now at the end of each and every production cycle, I'll have to do this. So what will I do? The first 20, I have 25 days right now with me. 1 to 25, I have 25 days right now with me. For the first 20 days, I will focus upon development. Okay. Let's imagine that let's put a cycle here again. So right now, you're working on what? The develop branch. So let's do a develop branch out here. So all the developers are merging their changes to what? The develop branch using a feature branch. The develop branch is protected. So the developers are coming with something known as a feature branch. After the changes merged, they are deleting this feature branch, of course, merging this change. After merging this change, I am saying what? You have a pipeline getting triggered, which is known as what? CI, continuous integration. Continuous integration pipeline is going to give you what? Artifacts. And this artifact you're going to take using something known as a CD pipeline. Taking this artifact into what? Multiple environments. And which environments are you taking, guys? This is the entire picture, right? So let's get this out here. Now these are the environments, and I'm saying you have a development, testing, or a QA, and production. So I'll say 3 different environments out here: dev, QA, prod. Now the dev and QA environments are for what? For testing your changes. So let's say dev and QA. I'm not including prod right now. The dev and QA are what? To test your changes. And in the 20 days, will I just test one change? Not really. My developers are constantly committing here, are doing a lot of changes here, and each and every change is going into what? The development and the QA environments. It's being tested. Each and every change is being tested so that I can consolidate all these changes and I can take it to what? The production environment. But the code should go into the production web app only at what? The 25th of December. Because that's when I promised the client to deliver the code out here. What I will be doing out here is that from the 1st of December to the 20th of December, I will allow the developers to do, I'm sorry.
A small doubt, sir.
Yeah.
Sir, actually, in Azure DevOps, when we are taking, all these things will go parallelly, no, sir. When we are develop team is there, feature team is there. Okay, when
Okay.
we commit to one code, it will go to
Okay.
continuous integration. When it will went to continuous integration, then it will move to the continuous deployment. And this develop QA, all these things also will move on parallelly, or that is
So
what
it
my
will
doubt.
move on parallelly. All these things will move on parallelly.
Okay, sir. Okay, sir. Thank you, sir. Got
Okay.
it.
So developers are committing their code directly from the feature to the develop. So they are doing this for what? The first 20 days. At the 20th day, I will tell that, okay, fine, you know what? I am now reaching a point, something known as sprint cutoff. Meaning, now no developer is allowed to do developmental activities. I'm saying no developer is allowed to do developmental activities. Let's imagine that this is a team of developers who are working for a project known as Android 9.0. So let's say this is Android 9.0 and what I'm working on. So I'll say this is develop Android 9.0. This is the development what I'm doing. And this Android 9.0 is now being internally tested. It's being what? Internally tested. And I'm testing these changes out on what? Development and QA. I am not giving it to the production yet. I am testing it on the development and QA continuously until the 20th of this month. Post the 20th, I will say, okay, fine. No more developmental activities are allowed. Because the next 5 days are only for testing before I give the code to the end user like us. I am an end user for Android. Before I give the code to that particular end user, I will now basically say I will test it for the next 5 days. So I will say there are no further commits allowed on this particular branch. So what I'll do is that I will lock my branch. I will do what? I will lock my branch. So in my case, I have a main branch. So initially I said, okay, fine, I will need a develop branch. I'll say this is develop 9.0 because this is Android 9.0. So I'm telling this is develop 9.0. I'm saying create. And I am allowing my developers to do a commit onto this particular branch using a feature branch, not a direct branch, using a feature branch and not a direct commit. And at 20th of this month, I will go here. I will say lock. I'm applying a lock on top of this branch, meaning there are no further commits allowed on top of this branch. It's only for testing. Development is now only for testing. And on the 23rd of December or 24th of December, after the test is done, after all these, after all these changes are done and etc., I will say I'll create a new branch here. This branch is called as a release branch. And since this is for Android 9.0, I'll say this is release version 9.0. And this is coming out of what? Not the main branch, because main branch doesn't have anything at this point. This is coming out of develop 9.0. And I'll say, okay, great. You're coming now out of what? Develop 9.0. And this is known as release 9.0. And even this release branch has branching policies. So I'll put something known as branching policies on the release branch as well. So I now have another branch known as release branch. So I pulled this release branch out of what? Develop branch. So now I have a release. Code is ready for this release branch, which is called release v9.0. And you have a team of developers who are working on this release branch because it's all developmental activities, right? And now I cut this branch when this is called a branch cut, and I pull this branch when at around 23rd. Now what I'll do is that I'll use this particular branch as my source code. I'll take this particular into the CI, generate an artifact, do a CD, take it to the development, take it to the QA, and on the 25th, with the approval from the client, I will go ahead and deploy it onto the production environment, and the user will now be notified that new update is available for Android what 9.0. This is how the software development will go ahead using Azure DevOps. Now the user will get notified that you have an update called 9.0 and all that stuff. And to support the user, just because I, let's say, get an issue in my software. Now let's say if you get an issue in your software, whom do you call, guys? Generally, do you call the developer directly? Who do you call? You call a call center, a technical support. You firstly call a technical support. So let's say now I am in production. My software is live. 9.0 users are using it. Software is live right now. This was what? The development team. Now I no longer will call this as a development team. After cutting the release branch and after my code is going live, I'll call this team as a production support team or a product support team who will basically be there to help my users out there. Okay. Now I have another set of people who are something known as a technical support team. Let's come here, who will constantly keep receiving feedbacks from the user telling that okay fine, these are the updates or these are, let's say, the issues in the code, this is what we need to work on, and etc. This technical support team will reach out to the development team using some kind of a ticketing system like Jira or ServiceNow or everything, etc. So you have something like ServiceNow and etc. And they will assign tickets to this particular development team to fix the issues, or in technical term, to fix the bugs. Now the development team now the production team, can it directly make changes onto the release branch, guys? Yes, no, maybe. It should not. Branch is protected. So now they will pull another branch here, and this branch is called as hotfix branch, because any change that you want to fix on production should be immediate. You cannot take a lot of time. It should be immediate, and that's the reason whatever branch that I pull from the release should be called as what? Hotfix branch out here. Guys, if you're not talking, can you please go on mute? Okay. Now I'm saying this is a hotfix branch. What the production team will pull, make changes, merge it back to the release branch, and then it'll go to the development, being tested there, go to the QA, be tested there, and now finally it'll go into production, and the user will now get an update telling that okay fine, Android version 9.0.1 is available. Till now I am working with what? 9.0. Now I am saying there's an update to this version. This version is called 9.0.1. Okay. Now what is then going to happen to this particular, I mean, there is code is gone live, we are great, like 9.0 version is on live, but will Google be satisfied just with 9.0? Is 9.0 okay for Google? No, really, right? Not really. They need to develop 10.0. They will have another team known as a development team, which are constantly working on a same cycle like this, but they are now using a develop branch, and that develop branch is called 10.0, and that will go to different cycles, and finally it will get released into production. This entire procedure is known as branching and merging strategies, and this entire cycle will form something known as the software development lifecycle, SDLC. This is how the software development will keep going ahead. Now we'll do this practically, telling that what a software development lifecycle is, but please understand an overview of it, like what we are doing, what we are getting into. I'm just setting a context to what we are getting into out here. I'm not going inside the practical part of it. I'm just doing a theory as of now. to tell you what a branching and merging strategy really is and what is the strategy we'll be following here. Any questions here, guys? Is this confusing? Understandable? Developers to make any changes into the from local machine, they can create a feature branch. They can also create a feature branch on the cloud also. Let's say I want to create a feature branch. I'm working on something. I'll say feature space Kiran, the work item number, something like 1, 2, 3, 4, 5, 6. I have a feature branch coming out right now, which is not protected, which doesn't have a policy. I can do any commit here. Okay. But the developmental activity will not go from the feature branch. The developmental activity will either go from the development or the release branch for production. They can also create the branch locally also. Okay. Any more questions here, guys? Any further questions here on what this is
Sir,
and why this is?
if someone joins newly into company,
Okay.
then if anyone should give permission to use those repos, sir, or he can directly use those repos. Some Git repositories will be there, no?
No, you cannot
Those
directly use the
repositories.
reports. Yeah, you cannot directly use Azure DevOps. You'll need someone to add you inside that particular Azure DevOps. How do we generally add it?
Okay,
Is
sir.
like this. So I have the organization, and if I want to add a user into the organization, I can go into organization settings. I can say users, and as of now, I am the only user out here. I can say add user, and I can give the user ID, and I can say the access level is basic to start with, and I can say add him to a project. In my case, it's an 8 a.m. project, and I'll say add him as a project reader, contributor, or an administrator. The same RBAC what existed on the Azure portal also has here.
Okay, sir. Thank you, sir.
Okay, I'll also add a user. I'll also add a user, and as someone suggested, we'll also do like two parallel windows, like one from an administrator point of view and the other from a user point of view, on how the user can basically go ahead, approve the changes and etc. Okay, any further questions here, guys?
Sir, after we are adding to this organization, then
Can
we
you give
can
me
use
one
all
second?
that
I'm sorry.
repos and all.
Give me 1 second. I'm taking a question offline. Just give me 1 second. I'll circle back to you.
Okay.
Yes. It depends. Like from 9.0 to 9.0.1, right? It'll be pretty much fast because these are hot fix updates. Because in 9.0 you had some bugs. You'll need to fix those bugs. Let's say 1 month. But from 9 to 10, it'll take at least a year. Because versions, right? Depends upon what kind of an update that you're doing and etc. Okay, someone had a question online. You can now go.
Sir, if once they add it to the organization as a user,
Hmm.
as per the given permissions like a contributor reader, then we
Hmm.
can use the repos, no, sir?
Yeah, you can use the repos then. Yes.
Okay, sir. Thank you, sir.
Any more questions here, guys? Like one resource group and you can create multiple lists. So you can do that. But the thing out here is that the reason I'm using three different resource groups is that I need the developers to have access on development resource group only. I need the testers to have access only on testing resource group only. I don't need the developer or QA to have access to the production. I need only DevOps to have control on all these three resource groups. So a user management is easy if I go with three different resource groups out here. And also the testing should be done in a better efficient way. Let's say that the development needs the app service plan to be on F1, which is good. The testing should need the app service plan to be on S1. Production should be on P1, V2. In that way, I can control my cost on where I'm creating, how I'm creating, etc. Okay. So user management and the configuration management will be easy for me if I go with multiple resource groups out here. Okay, so it depends. Like, some companies can also do multiple deployment slots. So it depends on, what exactly you're working on, how you're working on, what is the budget and all that stuff. Yeah, you need different app source plans for each and everything. It will be definitely. But if you want a very good security, you'll have to shell out some money there. But if let's say you're okay with, let's say, going with deployment slots, you can reduce your cost and go for deployment slots as well. So it depends upon. Mhm. You can control it. It's not an efficient control. It's not like the best control you can achieve. Also, if I let's say that the QA wants, let's say, the app service to be in a S1 plan, the deployment slot, even if you create it, it will still be in F1 only. So you will anyway ways increase the cost there. Instead of increasing the cost there, you can go for another resource group, have a better control, have a different configuration, and etc. So multiple environments will give you a better position to control who's using what. Any further questions here, guys? Okay, no further questions. We're good to close.
Sir,
Like this is the
one more.
yeah. Mhm. Please
Sir,
go ahead.
actually here source code is there, no, sir?
Right,
That source code, I think developers will write.
right, correct.
Uh, After writing developers, what's our task, sir? Our task should be we have to commit and we have to
No,
push
we are
pull
not
and
committing it. No, we are not committing it.
okay, sir.
We are creating the
Okay,
branches. We are making sure to establish the branch policies. We need to create something known as CI/CD pipelines for them, and we need to maintain
okay,
the
sir.
entire environment. So the developer's work is done when he commits the code into the branch. After the developer commits the code
Okay,
into the
sir.
branch is where we start.
Okay, sir. Got it, sir. Thank you. Thank you, sir. That's
Okay. Now I'm giving a bird's eye view of everything, guys. Like I'm making sure that we have a high level understanding of what we are doing. And once we go inside it, we'll start with each and everything. Like we'll start with, okay, fine, firstly branch policies and then next CI/CD pipelines. And then we'll see how the deployment goes on and everything. Okay. Okay, so that's it from my end today. Thank you.